Hey everybody, this is Trey with BlackFalconElectronics.com, and in this video I will be showing you Project Aurora, which is my Arduino controlled solar panel project. Now the point of this project is to have a storage unit that is obviously outside, away from my living space, where I can have my animals. Now, in order to power the Arduino Nano microcontroller that I have, as well as whatever electrical systems I have, such as inverters, heat emitters, fans and whatnot, I need to have a way to power it. So that's why I'm going to be connecting it to the solar panel as well as to a backup generator. So let's go ahead and get started with the demonstration of the project by showing you guys the Black Falcon Electronics mission board. So let's go ahead and get started right now. Alrighty guys, so here we are at the Black Falcon Electronics mission board. Now, I know this is a huge illustration, but we're going to go ahead and break everything down into its necessary parts and then describe how each subsystem relates to each other. So, first you have your two solar panels, then you have your two charge controllers here, you have 4 batteries here, and then you have a backup battery here, you have the Arduino controls here, you have your generator, your gas tank, your generator battery, and then of course you have your output. So how this works is the solar panels take the light energy from the sun and transmits that and transforms that into electrical energy. That electrical energy goes into both of these charge controllers. Now it's going to be connected in parallel. So when you connect things in parallel, you double the amount of electricity, the amperage of the solar panels. So you have double amperage, and then that goes into both of these charge controllers. Now, these two charge controllers both control different sets of batteries, the charge state of both two different sets of batteries. So this charge controller is in charge of maintaining these 4 batteries and ensuring that they are fully charged, while this charge controller just maintains this backup battery. Now, these 4 batteries here are connected in series and in parallel. So by connected in series, you have a positive connected to a negative, and it basically is linked together. Now, when you have them connected in series, you double the voltage. And they are also connected in parallel, since that's why you have 4, so you can connect 2 in parallel, 2 in series. And by having it in series, you double the voltage. By also having it in parallel, you double the capacity. So if these are 5-volt batteries, for example, they would then be doubled into from 5 volts to 10 volts. And then if the amperage, let's say it's 10 milliamp hours, it'll double into 20 milliamp hours. Now, of course, that's not what these batteries are actually rated to. That's just an example to show how it works when you connect batteries in series and in parallel. So this charge controller maintains the charge state of these 4 batteries. Now, if these 4 batteries get too low in voltage, then the outlet, which is this section here, is cut off automatically. Now, remember, I said there are 2 charge controllers connected to 1 set of solar panels. Now, the reason why I have this second set of the second charge controller is that this charge controller powers this, which is I termed as the Arduino solar eyes, as well as this Arduino here that connects the generator, battery, and powers the generator itself. So how does this work? Now, this backup battery will always, the point is for it to always be charged, because this will be a solid state battery. These will be flooded lead acid batteries. Now, this solar eyes monitors the power state of this charge controller. If the batteries are too low and the charge controller cuts the electricity, well, then this Arduino detects that the state of one of the pins that's connected to the output of the charge controller switches low. That means it's cut off. But since it's powered by this charge controller and this backup battery, there is no threat of this Arduino and this Arduino subsequently, since they're all connected in the same electrical system, cutting off. So when it detects that, it knows the batteries are too low, which means that all the inverters and whatnot are all going to get cut off. So to maintain the battery charge state, it sends an RF signal to this Arduino control, which controls the battery connectivity as well as if the generator is on or off. So when it receives a signal saying, hey, turn on, because the charge controller here turned the electricity off to the main system, this then, via a relay, connects the generator battery, and it also turns the generator on. Now, how do you go about turning the generator on? Well, the generator that I'm going to be using is radio controlled. So you would press a remote and that would activate it. But you also have to make sure that this battery to the generator is connected as well, because it can drain if you constantly have it connected, which is why I have it connected via a relay. So you can have it turn on to turn the generator on, or have this turn off, means the generator can't turn on. So the generator itself has a remote. It receives the signal, the RF signal from the HC12, telling it, hey, you need to turn on. So then this relay that is connected to the Arduino kicks on. So now this is electrically connected, and it sends an RF signal to the generator, a different RF signal, to the generator cut on. So by doing that, it cuts on, and the electricity now flows from the generator to the charge controller to the batteries, and it starts to charge it up. And then once it gets to where it needs to be, then the charge controller detects it, that the battery state is at an optimal level, cuts the electricity back on, and then the Arduino detects that it is now fully charged and the charge controller is sending that electricity. It sends another signal to tell the generator, hey, turn off and disconnect the battery, and then you're good to go. Now, the problem that is encountered is the generator can turn on, but of course it's going to consistently need gas, because let's say it's during the winter time. During the winter, these solar panels will most likely be covered in snow. So the generator would be the primary use for winter time, but it can only run for so long. And if I want to ensure that I don't have to constantly go out and make sure that everything is full, I need to develop an automated system. So what my intention is to have a pump that moves the gasoline from the gas container and then puts it into the generator so that it can go for several hours. Now, the generator, from what I looked at in the description, the item description, it says that the generator can run off 1 tank of gas for 12 hours. And I believe the tank of gas is about 5 gallons. Now, if I got a huge barrel, fill it up with oil, fill it up with gasoline, then I could use that generator for many, many days as necessary. Now, mind you, again, this only happens when its power is too low. So the generator is the backup, the solar panel is the primary means of getting the electricity. So that's how I plan to do it. It sounds like it's very cut and dry, but this is going to be a complicated system because I have never, ever done anything using gasoline, a flammable material. So I will have to do some experiments, which of course I will have posted on this YouTube, Black Falcon Electronics, and give updates on blackfalconelectronics.com so that you guys can see the results, whether it's something that I can do or cannot do. Of course, I will need several items to make sure that I don't die and maintain safety, because safety is #1 priority. Per my friend Crazy Russian Hacker, safety #1 priority. So I need to make sure that I do this safely and efficiently and as accurately as possible. Now, I already have 2 of these batteries. I just need to buy 2 more batteries. The backup battery I already have. I have a charge controller. I just need to basically get the Arduino program set up. I need to get this set up with the gasoline transfer system. And I just need to verify that everything works correctly. Now, another fail point that I see is the electricity moving from the generator to the charge controller. I need to make sure that the solar panels aren't negatively affected. I don't anticipate that happening, but if it comes down to it, I suppose I can use something like a large diode to make sure that there is no interference, but I don't really see that happening, honestly, but we'll see. Now, I'll also need some safety. So I'll need some, not relays, but some fuses that go from the panels the solar panels into the charge controller, so in case there is an overvoltage, whether it's coming from the generator or the solar panels, that it doesn't damage the charge controller, to make sure that the batteries aren't damaged, to make sure that the rest of the system on this output side isn't damaged as well as make sure that basically everything doesn't get fried. That's basically the point of these fuses, is electrical safety. So this will be a project that I undertake in the next couple of weeks or so. I'm very excited to see how this turns out. I already have the panels and whatnot, but doing this part with the gasoline and the generator is very interesting to me. So we'll see how that works, but I've already used the AC12 for the signal, so I know that that can work, but we'll see what ends up happening. So thank you guys for watching this video. Please like, share, subscribe, comment below, share this video with your friends, YouTube groups, any website, any Facebook community that you guys are part of. Share it so that we can share the knowledge and I can get good feedback on how I can go about accurately doing this in the most safest, accurate way possible. So I'll see you guys in the next video. Have a very blessed day, and goodbye.